Welcome to Ocean 201. We're going to continue our discussion of plate tectonics by focusing on divergent boundaries and convergent margins, two of our three types of plate-plate interactions. So we'll start with divergent plate boundaries. There are two types of divergent plate boundaries. So one is ocean-ocean, the other is continental-continental. And so these are when two plates are moving apart. In the case of ocean-ocean divergence, we are creating new seafloor. And so this is seafloor spreading, which we've talked about some. And from that, you get mid-ocean ridges and volcanoes and young lava flows. So for example, here, this is the Mid-Atlantic Ridge. It's relatively slow spreading. We've got the North American plate and the Eurasian plate moving apart. And you then have lava from the mantle coming up and creating new ocean floor to fill the space in between. The East Pacific Rise is another example that's fast spreading ocean-ocean divergence. Where you have continent-continent divergence. This, for example, is what happened in Pangaea when Pangaea broke up and you had South America and African plates moving apart, and that's how the Atlantic was formed. So as the continents split apart, new seafloor is created, and so you get rift valleys that form. And you then, for example, you get the East Africa Rift Valley. We talked about that a bit last time. That's an example of plate breakup and formation of new oceans. Spreading rates are between 1 to 8 centimeters per year. So you do get differences in spreading rates. Overall, even the fast spreading rates are still pretty slow relative to our lifetimes and really human lifetimes. For convergent plate boundaries, we have three different types. We've got ocean-continent, ocean-ocean, and continent-continent. So in convergent boundaries, when you have an ocean plate involved, you have subduction. So for ocean continental, the old seafloor is subducted. So in this example here, this is along the coast of South America, the Nazca plate and the South American plate. You have the subduction of one plate under the other. And the ocean plate subducts under the continental plates because they are less dense. Excuse me, they're more dense, not less dense. They're more dense than the continental plates, and so those subduct. We'll talk later with ocean-ocean, the denser of the two plates would subduct. The old seafloor is destroyed as it goes down to the asthenosphere, and it breaks up and melts, and you form a deep trench here as well. So here, this is the Peru-Chile trench. That forms from the subduction and underneath the continental plate. As the ocean plate subducts underneath the continental plate, it partially melts, and this starts to strip out volatile compounds such as water and carbon dioxide. These compounds change the melting point of the overlying mantle, which causes magma chambers to form, and these melt the crust, causing volcanoes. So you can see that depicted here. These volcanoes then will pierce up through the continental crust and form volcanoes. For example, in the Andes, these are high mountains in the west coast of South America. The ocean crust that's subducting is old, and it's accumulated sediments on top. These are lighter than the dense lithosphere that's subducting down, and so these will accrete on the continent. This accretion of material adds to the continental plate and helps also push up and form these mountains. One last point about ocean-continental convergence is that you get a lot of compressional stress, and that produces folding and thrust faulting. So that's what generates the earthquakes, both the shallower ones right at the boundary and the deeper ones that I pointed out last time that are occurring where these volcanoes are being formed. One other thing that can happen as you subduct ocean plate is that you can have formation of exotic terrains. And these occur when you have oceanic plateau or microcontinent that are scraped off as the plate subducts. And so this material, as it scrapes off and accumulates, this adds to the continental plate. And these have very different geology than the continental plate. And so you can see material with ocean sediments or the geology of the ocean plateau on the continental plate. And this is in part how you can get marine fossils up high in mountain ranges along the coast. And eventually this can move the subduction area as the plate grows. So if you have enough of this material accumulating on the continental plate, and that plate is growing, then the subduction zone can shift from here out further into the oceanic plate. Our next type of convergent plate boundary is oceanic-oceanic. And so this is where you have two ocean plates meeting. The denser of the two will subduct underneath. You get deep earthquakes forming here. As the old plate subducts, it retains its cooler temperature than the surrounding asthenosphere, and it becomes brittle. And as that breaks up, then you get earthquakes form. You similarly have stripping off of volatiles, which change the mantle melting point and drives volcanism. The volcanism here can create a volcanic arc islands. So these islands forming in an arc as volcanism is driven by this plate subduction. And so examples of these are the Mariana Trench and the Aleutian Islands. One other outcome of this is that you are generating light continental crust. So you're having all this transformation of rocks in the ocean mantle, and you're generating continental crust, so that this is how continents form, and how they are not form. This is how continents grow. Excuse me. Now, one thing that can happen is if the subduction rate exceeds the rate at which the two plates are moving towards each other. So, so if your subduction of ocean crust here exceeds the rate at which this crust is moving towards the ocean, moving towards the subducting crust, this crust can be stretched and thinned out. So you're subducting essentially too fast, and this crust is then thinning, and this creates a back arc basin. These are generally shallow seas, and they have large quantities of sediment eroded from the newly formed islands and the nearby continent. Now, finally, you have continental-continental convergence. This is where you see continents running into each other. Now, both the continental lithosphere in each plate is light. They're both not dense enough to subduct down into the asthenosphere. And so, for instance, when India ran into Asia, neither subducted. Instead, they converged, and you have the formation of tall mountains. So that's how the Himalayas formed. That's also how the Alps formed. And so you get mountain chains and thicker crust. You get very thick crust in these regions. You also get a lot of tectonic activity as the plate edges are compressed and folded. So just to go into a bit more detail about the collision of India and Asia, about 50 million years ago, the northern margin of the Indian continental crust hits the southern margin of the Asian continent. And so the Indian crust is a little bit denser, it's thrust underneath Asia, and the Himalayan mountains and Tibetan plateau are formed by the collision. So that's how we get such a high place in the earth. And so the tops of the Himalayas are sedimentary rocks that were scraped off the oceanic crust of the ocean floor that was destroyed when they came together. So the Himalayas are essentially old ocean sediment. So that's pretty wild when you think about how far and how high that sediment had to travel, but we're talking about very long time periods here. So that wraps up our discussion of convergent and divergent boundaries, and we'll discuss transform faults next time.